Hello my people. So let me show you how we can do the Fisher's exact test in R. Remember, the Fisher's exact test is just a statistical test used to test if there is any significant association between two categorical variables. And it is always suitable when the sample size is very small and also where the expected frequencies are less than 5. That is where we opt for the Fisher's exact test. So I'm going to use the stroke data. So the first thing that I'm going to do is to load the required libraries. And the required libraries, the first library that we are going to use is just the tidyverse. Then the second one is the janitor library into bracket janitor, like that. The second thing that we do is now to load the data, loading the data. We can just call it data. Remember I said that we are going to use the stroke data, read underscore CSV. Then after that I'm going to look where I stored the data. Yeah. So I'll just copy the data. After copying the data, I come back to R and paste it. Then I run. The next thing is to view the structure of the data. Viewing the structure, use the function called glimpse. So we write glimpse into bracket the name of the data. So this is the data containing 4909 rows and also 12 columns. It contains various columns, for example, gender, hypertension, and so on. So the next thing is to do data type conversion. Data type conversion. Under data type conversion, let's ensure that all character variables are in a factor format using the mutate underscore if into bracket is dot character, like that, then comma as dot factor, like that. Then I run it. Then also, for example, we can look at the association between stroke and gender. So let me ensure that stroke is coded correctly. So I'm going to write stroke is equals to, that is stroke is equal to if else data $sign stroke, data $stroke is equals to 1, let it be coded positive. Those will be positive cases. Then else, let it be assigned negative cases. Yes, like that. Yeah, but I can interchange so that it's also converted to factor. Let it start first. Then I run this one. Then the next step is now to do the chi-square. Remember, before you do the Fisher's exact test, is to do the chi-square first. So doing the chi-square is very simple. I can store it in an object called b, then I write chi-sq.test. Chi-sq.test, then the contingency table, that will be data, $gender, then comma, data, $stroke, like that. Then we run it. After running it is to check for the expected frequencies. Expected frequency. Checking for the expected frequency is just the chi-square result, $sign the expected. Sorry, not the observed by the expected. Expected is here, then we run it. Then we look at the expected frequencies. Remember, chi-square is only applicable where the expected frequencies are greater than 5. But if you notice one of the categories contains the expected frequency that is less than 5, like this one, now is where we opt for the Fisher's exact test. Now let's do the Fisher's exact test. Fisher's exact test, the function is always fisher.test from the janitor package. Then of course you mention your contingency table, and the contingency table is very simple. You just mention the name of the data, then the first column, then comma, still the name of the data, like that, then the second column. For example, this one will be stroke, like that, then we run. Then it is going to give us the results. You look at the p-value. When a p-value is less than 0.05, it means there is a significant association. But if the p-value is greater than 0.05, it means there is no significant association between the two columns. Now from our results, we can say that there is no significant association between gender and stroke, meaning gender is not associated with stroke, meaning stroke can affect both genders. So that is all about the Fisher's exact test. In case you want to understand more, you can reach out to me. I can guide you through all this. Thank you.